Okay, let's go through the same process in general. So I've made a sketch here with a horizontal line at y equals k and an arbitrary point at AB. And I'm imagining k is positive, but there's nothing in what I'm about to do that relies on that. K could be negative as well, and it would work out just the same. So hopefully, based on the problems you've done so far, you have an intuition that this will be a parabola and that the vertex is going to be halfway between this point and the line. And we think it probably will look something like this. But let's actually work out the algebra to confirm for ourselves that that's true. So we've got our two distances, d1 and d2. Oops. And we want it to be true, or we want to derive the curve consisting of all the points where d1 equals d2. So let's go ahead and write equations for d1 and d2. For d1, we've got the square root of, well, let's do this in a different color. For d1, we've got the square root. This is the point xy. So we've got the difference between the x-coordinates of this point and that point, so x minus a, and the difference between the y-coordinates of these 2 points, y minus b squared. So that's the distance formula. And then d2, we don't need the distance formula because it's just this vertical distance. So what I'm noticing is this vertical distance is, so that's y, and this is k. So this distance here must be y minus k. All right, so now we're in a good position to start doing the derivation. I'm going to do it without making any particular effort to identify simplifications, but then we'll look at the end, and a big lesson coming out of this is going to be how you can apply some of the simplifying ideas that we've learned recently. So let's square both sides. I've got x minus a squared plus y minus b squared equals y minus k squared. I want to cancel things having to do with y. So I'm going to leave this the way that it is, and I'm going to expand those two. So x minus a squared, and then here I've got y squared minus 2yb plus b squared. And then on this side, I've got y squared minus 2ky plus k squared. Okay, so let's see what cancels here. So I can subtract a y squared from each side, and those cancel. Let's move all the y things over to this side, and all the things that aren't y over to this side. So I'm going to add this to both sides and combine it here, and I'm going to subtract a k squared. So on this side, I've got 2yb because I added this minus 2ky. Meanwhile, I'll subtract the k squared, so I'll have a b squared minus k squared, and then this thing is just sitting there because we haven't touched it yet. Okay, great. So sometimes you have to focus on what your goal is here. Remember, our goal is to write y equals some stuff. So I see both terms here have a y, so let's factor out the y. So here I've got y times 2b minus 2k. And then I've got all the rest of this stuff. So let's go ahead, well, let's rewrite it. So then the last step to isolate y is going to be dividing by the coefficient, dividing by all this other stuff. So let's do that. And remember, there's two terms here, so when I divide both sides of the equation by 2b minus 2k, I'm going to divide each of those terms. So here we've got 1 over 2b minus 2k, x minus a squared, and then here we've got b squared minus k squared over 2b minus 2k. And here you might declare yourself done. But now we've got the second part of the learning for this. So if you look at this, yes, it looks ugly, but hopefully you can still tell that it's a parabola, because if you look for where the x's are, you can see that there is only one x term, and it's squared, so that should give you your parabola. Where's the vertex of the parabola if we look at the equation? Well, I can tell here that we are right-shifting it by a, which is what we're expecting to see, because we're expecting to see the vertex at the same x-coordinate as this point here, which is at A. Where are we expecting to see the y-coordinate? We're expecting to see this shifted up by an amount that's halfway between this point and the line. If you look at this whole constant on the outside is the vertical shift. But how do I interpret that vertical shift? It looks kind of ugly. So here's where simplifying can actually help you get some insight into your own equations. So let's go ahead and simplify this off to the left here. You might notice that b squared minus k squared simplifies or factors as b plus k times b minus k. Because remember, if you multiply this back out, you'll get b squared minus bk plus bk, so those cancel, minus k squared, and that's what you get here. So this is difference in squares. All right, and so then in the denominator here, let's factor out a 2. So I've got 2 times b minus k. Aha! And so now I see that these divide each other as long as b minus k doesn't equal 0. Remember, because I can't divide by 0 there. So b minus k doesn't equal 0. And you should always be thinking about the relationship between the algebra and the graph, the geometry. So what would it mean if b minus k equals 0? It would mean that they're the same number. And what would that mean? It seems like that would mean that the line y equals k is at the same height as this point. So what we've discovered here is that our derivation works as long as the point is not directly on that line. Okay, and what are we left over with on this side? We've got b plus k over 2. So let's put this back in here. So hopefully you recognize b plus k over 2 as being just the average between the numbers b and k. If I gave you 2 numbers and asked you to average them, think about what you'd do. You'd add them up and you'd divide by 2, and that's what we've got here. But when those 2 numbers are y-coordinates, the average between the 2 numbers is the same as the y-coordinate that's exactly halfway between the 2 y-coordinates that you're averaging. So this now makes a lot more sense, that the vertical shift really is halfway between this point and the line. Okay, what about over here? If we wanted to, I suppose we could factor out the 2 here as well. So 2b minus k. So this one's the scale factor. It controls kind of how shallow or how steep the slope for the sides of the parabola are. One of the things that I asked in my questions was whether it's possible for this scale factor ever to be 0. And hopefully you see the answer now is no, because the numerator is 1. And so it doesn't matter what you're dividing by, you can never make this equal to 0. It would be possible to make the denominator equal to 0 if b was equal to k. But the denominator 0 would mean that this was undefined. It wouldn't be the same as the entire scale factor being 0. Even though we can't make this 0, what we could do is ask what values of b and k make this very close to 0. Like if we wanted to make the scale factor as close to 0 as we wanted to go, how could we do that? So let's think about this. If we want this number to be very small towards 0, then we would want the denominator to be very, very big. So how would we make the denominator very big? It seems like the difference between b and k would have to be very big. So if the difference between b and k is big, let's go back and imagine that over here. Geometrically, what would that look like? It would mean that I would be pulling this point up and up and up and up, or dragging this line down and down and down and down. But the distance between them, the b minus k, that gap size is going to get bigger and bigger and bigger and bigger. So what I'm imagining here is the larger the gap size, the smaller the scale factor, which means the shallower the parabola. And so hopefully you can have like an animation in your mind where you imagine making this bigger, and meanwhile the parabola is getting shallower and shallower. So what I want you to take away from this is being comfortable with the idea of deriving an equation that has no numbers in it. Instead, you've replaced every single possible number with a constant. as a way of generalizing the problem. So just being comfortable with that algebra is the first step. And then second, realizing that you can apply some of the simplification things that we've learned, the factoring patterns and so forth, in order to make your final result look simpler. And we even could have made the algebra easier by doing some of that factoring earlier on, and that will be even more true in some future problems that we'll do. And then the third thing is just realizing that you can and should try and understand what the algebra of each term is telling you about the generic situation. So the goal is not just to get a formula and put a box around it. The formula is to understand, like, what are the b and k telling you about this term? And, oh, that's the vertical shift. And, oh, the scale factor, well, what's possible? Could I make the scale factor negative? What would be required? Could I make the scale factor 0? And how does that relate to the locations of the point in the line? So your goal in math is always understanding a general situation as deeply as possible. And this is one of those tools for how you can do that. I hope that this was helpful.